Okay, hello and welcome to Dakota Prep's tutorial on finding non-coincident demands for our service size for a residential or dwelling unit, that is. Now, I want to get this out of the way. I know I've already mentioned this in another video. I'm a non-coincident guy. You're not going to change my mind. I'm non-coincident. Some of you non-coincidental folks, like you can just be angry with me. I'm going non-coincident. So non-coincident, non-coincidental, whatever you want to call it, it's pretty much the heat and air clause, right? When it comes to sizing services for residential or dwelling units. Okay, and now the rules for this, there's a couple that are important, but 220.60 is going to be extremely important, obviously. In addition, sections 220.50 for AC, sizing AC or using your AC load to determine your demand, and 220.51 for heat will be used as well. Now 220.51 straightforward. It just says, hey, 100% of your heat. 100% of your heat. There's no derating, there's no additional demand or anything like that. Whatever your heating load is, it's 15. In this case, it's 15 kW. That's the number we're going to use. 15,000 watts or volt amps. It says kW. We'll go with kW. Now these are interchangeable. Watts and volt amps, when it comes to the requirements that you find in Article 220, they're kind of the same. They're both just measurements for power, right? Watts or volt amps, both just measurements for power. In this case, they are interchangeable in Article 220. So, okay, 15,000 we'll say watts or volt amps, whatever. Now for the AC though, not so straightforward. It tells us, you know what, we got to go look in Part 4 of Article 440. 440 is what covers air conditioning. Now what's a little strange about that is that Part 4 are kind of the rules or guidelines for sizing conductors. So you're using conductor rules to find the load, right, for your AC. But it turns out, luckily, it's pretty easy. It's just like any other multiple motors on a branch circuit or whatever, or feeder. We go 125% of our largest load plus all other loads. So in this case, I want to make this a different color. So AC, it's gold, right? Blue makes sense. So 3,500 is our largest load. We need to apply this 125% demand factor to that. So it's actually a little larger. So we plug this into our handy trusty calculator, and it tells us we get a total of 4,375 volt amps. Okay, 4,375 volt amps plus our other loads. In this case, we have another load that's 800 associated with the air conditioner. Okay, gives a grand total 5, 7, 8, 9, 10, 11. Carrier 1, 5,175 volt amps. Okay, now is where this guy, 220.60, comes into play. 220.60 says, hey, your air conditioning and your heat are unlikely to be used at the same time unless you're a crazy person and you don't have a thermostat. If you have it's that word likely that's helpful here. Hey, they're not likely to be used at the same time, right? So you only have to account for the larger of the two because they're non-coincident. Well, obviously 15,000 is much higher than 5,175 even after applying that 125% demand to our largest load, right? So our green light correct answer is, well, the larger of the two, 15 kW. That's what we would add into our overall demand to size our service for this dwelling unit.